Good morning, everybody.
Morning, Dr. T.
Good morning.
Dr. T.
Good morning, Dr. Terrell.
Good morning, Dr. Zero.
Good morning. Good morning. What are we going to do today? Chase. So many hard problems in these problems, and I am sorry about that. But why don't we talk about micelles? We can do the we can do question 9, 13, and 19.
Dr. Terrell,
Yes.
is the first lab report due this Friday by any chance?
This Friday?
Yeah.
That was on campus and then it changed. Is the change real?
We'll have the why don't we have the lab reports due after spring break? And so the homework is still due Friday. So we'll do homework stuff this week. Then, oh, it's so weird. I said next Friday, and like 3 people disappeared. Like bum bum bum. It's like what? Hold on. Where's my video? I want to see some faces here before you disappear. Oh my God. Let me see if I can get my death cam here. Wait, this is my life cam. See if this one, oh yeah, that one's gonna work, I think. All right. Fook is here. How are you, Fook?
I'm good. How are you, sir?
Good to see you, buddy.
Thank you.
I missed you.
I miss you too, sir.
Oh yeah, you missed harassing me is what you did.
No, I miss your kindness and your joke.
He's such a good guy. He can't even harass properly because he's too nice. I don't know what to do with him. Yeah, so due dates and stuff, right? So homework's still due Friday, right? So we'll finish the homework this week. Next week, last week before spring break, yeah, can't wait. Next week on Tuesday we'll review, and on Thursday we'll have the exam. And yes, the exam will occur at the ungodly hour of 7:30 a.m. But it'll be over quick. It's kind of like being, facing the firing squad at dawn, So what the hell?
Dr. Terrell. Dr. Terrell.
Yeah. What are we gonna
For the exam next Thursday, is it gonna be free response multiple choice, or how is it gonna look like? How is it set up?
Well, oh, there you are, Solomon.
Yeah, my window's weird. It shifts every 30
no, you lean back
seconds.
No, you lean forward. Then you. Oh, now you're gone again. Okay.
I'm just gonna wait. Just get right there.
There he goes. There he goes.
But yeah, I'm here. So.
So I've been thinking about it. I think probably 70% of the exam will be like easy questions, like from the homework. Yeah.
Okay.
Like that'd be like the drag and drop, mix. What is this,
Okay. The exam's gonna be on Canvas, correct?
Yeah, it's gonna be on Canvas. It's gonna be using the dreaded lockdown browser.
So does that mean that we won't have access to Excel during the test?
That is a happy thought, isn't it, Brandon? I think probably, yeah. Yay, no Excel. Hey, Dylan. Nice to see you, buddy.
Hey, Dr. Sarah. So we have to do the exam during class time because I have to go into lab next Thursday at 9 a.m. Usually I don't come into lecture on those days because I have to drive to school.
No. No lab next Thursday.
So
That's going to suck. Can I do that? Can I just friggin' cancel lab? I tell you what, I have a plan. Let's cancel labs all next week.
And just push labs a week back, so we'll go like a week longer than we were planning. I think you had some like makeup labs planned in there anyway.
That is such a lovely background. I can't even talk.
Lake Observatory.
Lake Observatory?
Yeah, you can kind of see the couple of smaller domes there.
Yeah, that's super nice, super nice.
Oh yeah, there's San Jose.
Yeah. So yeah, if we do this, if we do my evil scheme, then we will run a week late into the semester. But I think we've got a couple weeks on the end that we can play with. I could be wrong.
Yeah, I thought you did too, so I think we're okay.
Yeah, I think we're okay. Because part of the reason is that on Wednesday of first of all, next week is hell week for me. Hell. Because we have 2 candidates coming to campus. And I'm just going to be dog tired because I'm going to be in meetings from morning to night. And then I've got to get an exam ready for Van because I know she's going to be looking over the exam very carefully, trying to find any mistakes. Right? That's right, Jonathan. And so if I cancel lab next week, that'll give me some space to do what I need to do. Interview candidates, get my COVID vaccine, my second shot.
Congrats on the COVID vaccine.
Yeah. And take my son to get his driving license. So that might
What car is your son gonna drive?
Yeah, and these are all anyway. So I need some advice from y'all, confidentially, right? And that is, I had to lie to Kaiser to get my second shot, right? I got my first shot with the county, and then a couple weeks ago, the county said, "Oh, you told us you were Kaiser and we gave you the shot, but we don't like you anymore. So F you and go find your second shot elsewhere, dude." Right? And so I thought, oh geez, what's gonna happen, right? And then Kaiser sent me an email saying, "Oh, this is terrible that the county has canceled your thing. Bye." Right? and so I went on the freaking Kaiser website. I'm like, I went on the phone, I went on the website like multiple times. Every time I got on, I just go into some hole and boom, it'd be over, Talk to a nurse. Beep, beep, beep. Hey, I'm sorry, you can't talk to a nurse, sucker. Beep. And finally I got into a part of the website where you could sign up for your first shot only. No option for second shot, right? So I fucking signed up. So I've got to go.
You gotta show me because I'm struggling to do that. You gotta show me how you did that if you can. Because
I'll try.
Okay, because I have everything to get my first shot. I'm allowed to get mine, but I just can't get through to Kaiser. I haven't met anyone who's been able to.
Right.
So if you remember how, can you let me know?
Dylan?
Possibly.
Yeah, so I was gonna say, when me and my mom went in last week,
Yeah.
they asked us if we were here for our first or for our second.
Oh,
They didn't even ask us like, oh, there's like, is this your first shot or your second shot?
I'm gonna get burned here, aren't I?
So
You see what I'm thinking?
What place was this at, Dylan?
Since then, I looked at it. Oh shit! Is there a difference between the first shot and the second shot? Can I
No,
just?
you can go
bruise?
to the website, Dr. T. You can go to the website and sign down for the second shot. Kaiser will send you an email for your second shot.
How?
Really? There's the phone number for the county. Did you call them and talk to them?
County? Go back to the county?
Because I do my second shot with regional medical center, and I have a trouble like you too. And then a couple of days before my second shot schedule, they send me an email link.
They tried to cancel you, didn't they?
They say if I get my first shot at regional medical center, I have to go back there to get my second shot.
Bastards. Well, they told me I could not go there. So, okay. So there's four possibilities for me. One, they're just going to tell me to take a hike, right? If I could be honest, they'll say, oh, dude, you lied. Get out of here. You die, right? Or I could continue the ruse and say, okay, I want my second shot, or I want my first shot, right? Then they say, oh, here we have J&J. I'm like, no, that's not the right one. Well, J&J actually might work, right? Because it's only one shot. But then the other one is Moderna versus Pfizer, right? I got a Pfizer first shot, and I cannot take a Moderna second shot. That won't work. So, anyway, wish me luck. I'm probably going to be taken away in handcuffs and stuffed into a cell in Guantanamo.
Dr. Taylor, I have a quick question.
Yes.
When you go get your vaccine, do they tell you which one you're getting, or can you choose which one between the Pfizer, Moderna, and then the new Johnson & Johnson shot?
That's a good question. I don't know.
Because I don't want a Johnson & Johnson shot. It's 60%.
Cold.
Yeah, I think it's randomized.
Oh, hell no. Okay, thanks, Thomas.
I'm taking a lottery, huh? Put your life on the line for lottery. Fook says we cannot choose. Where are you, Fook? There you are. You're not even here.
I'm here.
If you're not here.
I'm here. I just look ugly today, that's all.
You're not here. You're a disembodied voice.
I'm here. Hello. Hello. So yeah, I heard that Pfizer is like more side effect though. So I heard. Not sure.
I know. Okay. Good. So let's talk about quenching. All of y'all know what quenching is, right? Quenching is when you have something fluorescent, you throw another molecule in and it goes dark, right? Thank you, Van. We cannot choose. All right. You guys are on my case. Now, Fook disappeared again. Okay. So
I'm still here.
When you throw something in and it goes dark, right? So, as an analytical chemist, I have a problem with that, right? Because for me, signal means it's a positive thing, right? Put chemicals in, you get more of something, right? But in this case, you get less. A little bit like absorbance. Took me a while to absorb absorbance too. For quenching, there's a thing called the Stern-Volmer equation, right? And here, let me see if I can get my stupid sucking camera on here. I have something on my calendar today that says quenching, 8 to 9 a.m. I'm like, what in God's name is that? No, please come back. My document camera is not working. because you can see my face, so I can't use a second stupid fucking camera with Windows or whatever. I gotta put you guys. I'm gonna try putting you back on the nose cam. That'd be video. Integrated webcam. Nose cam. And let's see. Try to start this. Ah, there we go. There we go. Okay. So, the Stern-Volmer relation basically, oops, sorry, I gotta share my stupid ass. Share a stupid screen. There we go. The Stern-Volmer plot, right? And there's a quenching constant called KSV. It's really a rate constant. It should be probably lowercase, but in any case, the fluorescence at 0 quencher divided by the fluorescence at some quencher concentration Q is equal to 1, right? Because when quencher is 0, F equals F naught, right? Plus KSV times Q, right? And Q is a concentration. You know, so so basically, the first question on this is question 13, and it's basically an Excel type problem, you know, because they give you F data and concentration data, right? And they start with, you know, 17.325 and then 0, right? And then, you know, 15.231 and then 1, like this, right? And what you need to do in Excel is you need to make a column F0 over F, right? So, oops, F0 over F of Q. That sucks, man. This is F0 over F of Q. I can't write a Q this morning. Anyway. And so you'll take, you know, you'll take whatever it is and divide it by this value. You know, so this will be, you know, 17.325 divided by 17.325. And the next one will be 15.321 divided by 17.325, etc. down there, right? So then you get the slope and intercept of this guy. And the slope will be KSV. the quenching rate constant. So let's see. Think about that. Oops, sorry, there's somewhere here. This is question 18. Okay, so you can see here that the well, I need to make this larger, but basically I just plotted this data out, and I threw away the first point, right? So then that's not really a point because you don't have an F, you just have F0. I don't know the answer, I just threw it away. And then the answer came out to 201.8, and then the intercept is 0.99. The intercept should be 1, right? And then it came out to 201.99, so that's good enough. So that's basically all there is to this problem, right? You can see that, you just take the quotient there. And then same thing there. It's this value over this one, right? So because it's upside down, this curve will go upward, Let's see. So there's F0 over F, and there's Q. So it's a straight increasing plot. So that's an easy one, right? The next one is a little bit tricky. And there's one thing that I don't like about this book. It's how tricky the questions are, So let me go back to the document comma here. Right, and the next one is a simple quenching problem wrapped up in a tricky micelle problem. So let me talk about micelles a little bit here. There we go, we're in focus. So, I think I know something about micelles, but I really only know very, very little, right? The idea of a micelle is that there's two things. There's liposomes, which is, fatty head groups. Wait. Oh, that's wrong. A liposome has a bilayer. And so it's It's got an interior and an exterior. And it's got a fatty membrane. Right. And this is a liposome. A micelle, and liposomes, you have to make them. It's not hard, but you have to make it. They have to have the fats in the right composition. You have to extrude them out of a filter, a nucleopore type membrane filter, or you have to sonicate things just right, and then you can get liposomes. A micelle, on the other hand, they form spontaneously. And they are simply, in 2 dimensions. They just have an interior and an exterior. And the interior is nonpolar, right? And the idea is that liposomes, they form when the surfactant concentration is greater than the CMC. That's for the critical cell concentration. And they do so under equilibrium control, right? So if you add more S, you get more micelles. M is the micelle concentration. And as is very dispiritingly typical for good old Dan Harris, he starts this in the most opaque way possible. He starts with the Poisson distribution of quenchers in micelles, and it's like, what the bleep are you talking about, man? What class is this? Friggin' biophysics 275, or is this Chem 155? Right? So he talks about, and then he goes on and he just blasts you with shit. So I decided to pull it apart a little bit. So let's do a few definitions here to start with, right? We've got things like surfactant. We have things like M for micelle. We like CMC. And this is a constant. Right, at a given temperature, right? And then there is Q, of course, right? Okay. And there's one that we never touch on, which is fine. It'd be the fluorophore concentration. Yeah, that's fine. That doesn't matter really. But then there's a few other interesting concepts. Like there's Q bar, which is equal to the number of quencher molecules per micelle. And that's simply equal to Q over M. And then there's an important concept here, which is unstated because it might be wrong, but I think it's assumed. And that concept, Casey, is that when there's a quencher in a micelle, that quencher is dark. And if there's one, or there's two, or there's three, however many, they all make it dark. Right? Good. So, now, another thing that's not stated here explicitly is that the quencher is only soluble inside the micelle. That's another important concept that is swept into the rug here, right? As the same with the fluorophore. So if you add quencher or fluorophore, they all just go to the interior of the micelle. Okay? So, there's another interesting concept here, which we need to get in here, which is NAD, and this is the number of surfactant molecules per micelle. And the way that this is tied into everything else is that NAD is equal to the surfactant concentration minus the CMC divided by the micelle. Oops. Sorry. Wait, divided by the micelle concentration. So the CMC concentration, this is the surfactants not in a micelle. Okay. And this is total surfactants. So this is, so in the numerator here we have surfactants in micelles divided by the micelle concentration. The numerator is a concentration. And I'll just replace it with this concept of surfactants in micelle divided by the number of micelles. And which of these two values will be larger, the number of surfactants or the number of micelles? Cynthia?
Micelles?
The number of micelles will be larger or smaller?
Larger.
The micelles themselves will be larger, but their number will be smaller.
Oh yeah, smaller. Okay.
Yeah. Thank you. So this number is greater than 1. So NAD is greater than 1. It's just like, you just gonna have to roll these things around in your head a little bit, and then you get more comfortable with it, right? And so, NAD might be 50 or 100 or something like that, because you gotta, there's a minimum number of molecules that you can form a sphere with, right? Because the micelles are roughly spherical. I like to think of them as dynamic blobs. As a matter of fact, probably they're like sea anemones. Who had the sea anemone background? Van, come back. If you can. So anyway, there's a sea anemone. Okay, so I'm just distracting us because I'm wasting time. So let's see here. So next comes the math. And then the math part here is, it's kind of weird. Like, why would they even mention this shit? Especially up front. So, what are you talking about here, But don't worry, it'll get better. So then you got P sub n is equal to Q bar raised to the n power divided by n factorial times e to the minus Q bar. And what the hell? What the? What is that? Right. So Q bar is the probability. Wait, no, is the number of quenchers per micelle, right? I didn't even. Yeah, I put that as Q over M, right? So this is the number of quenchers per micelle, right? And then this is the probability that there are n quenchers in a given micelle. right? Can you guys see the? Yeah, you can, can't you? Hopefully you download it. So hopefully there'll be cries if that's not happening, right? And there's just some special cases when n equals 0, then p sub n is equal to e to the minus p bar, because anything raised to 0 is 1, and n to the 0, and 0 factorial is 1, right? So this is one special case. And you could just plug it in, it doesn't really matter. But then, you know, so this is just a weird probability distribution, and it's discrete, right? Because there's only n equals 0. You know, if q bar is less than 1, right? If there's less than 1 quencher per micelle, on average, let's say there's 0.1 quenchers per micelle, then it's much more likely that there will be 0 quenchers in a micelle than there will be 1 quencher in a micelle. Does that make sense, Solomon?
Yeah, it did actually. Oh, but
Yeah, because like, you know, let's say we have a whole glass of milk, right? I mean, it's just chock full of micelles, right? And we throw in 1 molecule of quencher, right? And it goes into one of those micelles. Well, the probability that a given micelle has no quencher is almost unity, right? It's as high as it can get, because there's only 1 quencher in the whole bazillion quencher micelles, right? Let me say that micelles, right? So if Q bar is less than 1, Q bar is the average number of quenchers per micelle, or the average number of quenchers per micelle, right? And so then, and it just goes down from there. But if Q bar is greater than 1, then there's a different relationship, right? If there's on average like 3 quenchers per micelle, then this takes a different form, right? So we've got, you know, 3 cubed over 3 factorial times e to the minus q. So it's a little bit different, right? And I think this normalizes such that the sum of the I don't know why I wrote that, because we've been talking about quenching thing. Because you know, so basically what this will look like, 0, 1, 2, 3, 4, 5, 6. This is for Q bar less than 1, which is the regime we're going to work with, right? So another thing here that we can, so let's just take this as it is, boom, back, done for now. And let's move to the idea of the average micelle concentration, right? The average micelle concentration is equal to S minus CMC over N average, right? and Q bar is equal to Q over M. Oops. Q over M. These concentrations, right? So now we can start to integrate these things. So like you can substitute in for M there, right? Then we'll put that into the exponential equation, right? And we got Q bar is equal to Q NAV over S minus CMC. Right? And therefore, P sub n is equal to it's just the same equation, just written out in all of its ugly glory. And then next what we have is if you just want to think about P of 0, right? Let's think about P of 0. P sub 0. Probability of 0 quenchers per cell. This is one that really got me head scratching, right? They said, oh, well, this is equal to the log, equal to IQ over I0, right? What the bleep? I just didn't really get that, you know? And so, so if we take the log of this, so if we think of P of 0, this is equal to IQ over I0, I think, right? The quenched fluorescence intensity over the native. And so this is really the leap of faith here. Because a miracle happens, this is the statement that P of 0, right? The probability of finding a 0, a bright, the probability of finding a bright myself, all the other ones are dark, right? If they have like 1 or 2 or 3 quenchers, they're all dark, right? Probability of a bright myself is equal to IQ over I0. There could be 1 over that. I think it's either this or this to the -1. I'm not sure. Just go with me for a sec, right? Such that, let's see here. IQ over I0 is equal to e to the minus q, and then for p of 0, right, is equal to e to the minus q over m, which is equal to e to the minus q NAV over S minus CMC. And so all of this weird mental gymnastics, right? This term here, this term here, this term here. This is all about using IQ and I0 data. IQ over I0 versus Q data to compute NAV, the average number of surfactants per life cell. Oops.
I think
it is I0 over IQ.
Sorry?
I think it is flipped. I think it's I0 over IQ.
I0 over IQ. So okay. This is probably I0 over IQ here, right? Is that what you're saying?
Yeah, I think that's what's happening, sorry.
Okay. Okay. Sorry. Looks like I'm in the second grade now. I probably am in the second grade cognitively, but whatever. I don't feel any smarter than I was in second grade. I feel significantly dumber. I think that's the way everybody feels. Do we not all feel dumb? I friggin' feel dumb all the time. I do. It's just terrible. I'm looking, it looks like I'm looking at the ceiling, but I'm looking at y'all's faces, whoever I can see. You know? My buddies, Casey, Cindy, and Solomon. Everybody else who's got their cameras off, at least they're here. Let's see here. So what we do then is we're going to make a plot of the log of I0 over IQ, right? And versus Q. And this will give us, this will give us some sort of dimension. Let me see if I've got that one on top for us here. So this is problem. What problem is this? 19. It's in a different spreadsheet from this one. Yeah, this is it. Okay. This should probably say 14. Question 14. So let's see. Hold on, let me do a different chart here. So basically, these are the data from the book, right? We've got Q, that's on the x-axis, and then what we plot on the y-axis is the log of I0 over I sub Q, right? So there's 1 here. This is just, that's 1. Okay, these are the data, right? And then the log of I0 over IQ is just the log of that number, right? And so the slope of this line here is 0.044 or 0.0440 micromolar, right? That's the slope of that line. So what that means is that, or it's either 0.004 micromolar or 4 per micromolar rather, or 4 per millimolar. If it goes the opposite way, right? If you're dividing by the unit, as the unit gets, I don't know how to say this. You know, trust me here. I hate it when that happens. So this number goes up to 4 per millimolar, right? And then let me grab my notes back here. And we can go back to here. Documents camera. And so, basically, you take the slope of that line, right? it's the slope is what you multiply that Q by, and you multiply Q by NAV over S minus CMC, right? Oops, sorry. And then so NAV is equal to slope times that, and you can find NAV, right? You just solve for NAV here, and then this is how you get a millimolar, right? And this is slope times S minus CMC, right? This is just working on the slope. And so that means that there's about 56 molecules per micelle, right? Then you can use that to calculate the average micelle concentration, 0.227 millimolar. And you can use that 0.227, or then you can use that 0.227 and the quencher concentration. Now this is just specified in the question. So this is a sort of it's a break from the actual intellectual continuity of the question, right? It's okay now, does not tell me what Q bar is. The Q bar is always a function of Q. Right? So there's it's like a discontinuity in the question, right? So it threw me off for a while too. Like this is now we're going to go to a special case. Right? And Q bar will equal Q over M, right? And the M value will be a function of S, and the Q value will be a function of, the obvious one, And so Q bar is slightly less than 1, right? And then from here, this one falls out pretty easily, right? Where we have 0, e to the minus Q bar, right? Which is 0.397, right? E to the minus 0.923, and then we can substitute 0.923 in there and there, and it's kind of like this times this, right? 0.39 becomes 0.36. Then we put a 2 in, we get 0.169. So this kind of tells us, if we have one, on average, one quencher per molecule, then the probability of no quencher in a given micelle is about 0.4, right? So about half the micelles will be bright and half will be dark. Right? The whole entire brightness idea is built on on this leap of faith here, right? That they make us go through, which is that I0 over IQ is equal to E minus Q bar. Right? And I think what this means is that I0 is greater than 1 and I sub Q. They always, or I sub Q will always follow this e to the minus Q relation. That on average, the bright micelles versus the dark micelles will follow this negative exponential function. And then P sub 1, P sub 2, P sub 3, you can't measure them because they're dark. You can only get to them theoretically. And I mean, it's like, I don't know. I don't know, who cares? But now we know.
I care. I care because I know what I'm doing now.
So you can calculate the number of little fat globs in a glass of milk that have a particular molecule in them, You can calculate the fraction of those, But I don't know. It's like mental gymnastics. This problem is really mental gymnastics. And I know that it's probably clear as mud to all of you right now. And all I can say is you gotta, there's a number of transitions and you gotta sort of, sweat over them a little while. And then you can get through the problem. I mean, you can get an A in this class and never even have a clue what this problem is, I don't care. I'm not going to put this on the exam. I can't. How can I? There might be some concept. There might be like one problem that's a concept related to this, right? But it can't be deep. I can't put a deep concept like something super deep that I don't even friggin' know. What should I ask about this, man? Think of a question that I can ask about this problem.
I have hello question. Hello, Dr. T.
Hello.
I have question about question number 13. How can I find F0?
Question number 13.
Yeah,
I think that's the one that I started and I was like, oh shit, this is hard. I better do this on Thursday. Hold on. There's a question 13. Oh, okay. Yeah, F0 and question 13, that's just the first value. So you have to throw away the first data point.
Is it the F1? It's not they have the F and iodide ion.
Yes.
So the F is the F0. It's different.
The first F is F0. F0 is the F without any iodide. You guys had a chance.
The first F is F0, but they didn't give us. How can we calculate that one?
Well, F0 over F for the first point is 1. Okay, let me go back to it.
I'm stuck on that one. Can you please say that?
Tell you, Van, you're missing out. You're missing out big time. This is it, right? The F0 over F, I didn't even calculate it for the first point, right? But this number is just going to be 1, right? No. Okay. Does anybody else want to tell me what question to ask about quenching in micelles on the midterm?
Are we going to have a review session for the midterm next Thursday?
Yeah.
You said it's going to be next Tuesday, correct?
Yeah.
Okay, I just want to make sure.
Very bad. very bad question though to ask at this moment in time. Cynthia, you don't want to take this opportunity? Oh, because I've got a bad reputation. I've got a bad reputation already, right?
No, you don't. You're a fun teacher. I'm like,
terrible reputation because I change my mind. I change the rules all the time.
it keeps us guessing.
Do you want to tell me what to ask on the midterm for myself?
What subject should we study the most for the midterm?
I'm giving you a chance here.
A
super easy question.
Pick the early stuff.
What?
Pick the early stuff. I understood the early stuff.
Okay. The probability distribution.
Please. Yes, please.
Okay. Did anybody understand the probability distribution?
Honestly, no.
Choose.
No,
Who cannot choose?
I did not.
It's wrong to choose. Well, no, I'm saying you choose. Put yourself in my shoes. How about if you add more quencher, does Q bar go up or down? Something stupidly easy like that. But now I took that one.
It'll be a bonus point for the 15 people here, and everyone else, well, sucks to be them. I'll teach them not to come to class.
Like +5 extra credit points for the midterm.
I'm not allowed to be overtly mean to my class.
Well, it could be like roll call, like, oh, you didn't show up to class, so you lose 5 points. Those 5 points went to your midterm. That's it. That's it to do.
I have to give though. Okay, pop quiz. What? Oh shoot! It's 8:47. I can't give a quiz after class. Bye, everybody.
Professor, really quickly.
John Luca. Yes.
You said the test was next Thursday, correct?
Yes.
Oh, okay. Okay. Thank you.
Last Thursday of the before spring.
Dr. Terrell, are you going to cancel lab days?
Then the first lab.
He already did.
Is due after spring break. I don't know.
Okay.
Let's make Crystal Violet be due after spring break.
Okay. Thank you.
So it'll be due on April 8th.
Yes.
Okay.
I'm gonna go with that, and then I'll put it up on Canvas.
Okay. Thank you, Doctor.
All right. Bye, guys.
Thanks. See ya.
Bye, Dr. Terrell. Have a nice day.
Thank you, Dr. Terrell.
Okay.